Einstein. Here's environmental quality, still outcome number one, but part two, topic two. In a normal, healthy ecosystem, many species may access the same food source. But human beings, we have an advantage, right? We can specialize our food sources through artificial selection. You'll never see wolves doing it. Wolves will not capture deer and capture old, slow deer and get them to breed so they have a permanent food source. We as humans have done that as well. We tend to use pesticides to control our competitors or pests. So that could be to control herbs, we use herbicide. To control insects, we use insecticide. To control fungus, we use fungicide. Okay? And some of these are designed to kill, some designed to make things go away. So you've probably seen those, those little citronella candles that you burn. They make the insects go away. But then there's also Raid. When you spray Raid, that actually kills the insects. And there is an interesting story about Mr. Tierra, not me, Mr. Tierra, my dad, Mr. Tierra, who invented a chemical called whitewash. It's a fungicide that's still being used today. Mm. Oh, yeah. There is a picture of my dad, Mr. Tierra, who discovered whitewash, made the company lots and lots of money. Why have we done this? I don't want to go there. And then here is here's the abstract so you could see. I mean, I know you believe me, but there's my dad, DeLale S. Tierra. In his younger day, he was really, he's still really smart, but he was really, really good before he had dementia. And that was one of his, things he was most proud of was the discovery of this chemical called whitewash. And the company who invented it, the company who marketed it made billions of dollars. And I often ask my dad, why didn't he walk away when he knew it was going to be a big money maker? And he basically said that that would be dishonest. And so my dad has a really strong lesson for honesty. All right, back to this. Some issues with use of DDT. DDT was a pesticide used to kill insects. It was really good. It was very cheap. It was easy to make. You didn't need any special training to use it. Really, all you had to do was know how to push the button and wait and aim the wand. And it was a really cool chemical. It was originally not used to kill insects. The design was to kill lice. Well, when people came back from World War II, they had lice, and it turns out lice had uh, had typhus, and so that was a disease that they were able to wipe out by using this. So at the end of World War II, people would line up on the beach. The truck would drive by. It would spray them. It would kill all the insects, including the lice that had typhus, and people would be healthier. All you had to do was hold your nose, close your eyes, and that was it. Had a shelf life of over 100 years. So once they made it, it could sit on the shelf for 100 years before they had to use it. Amazing. And in the 1950s, they thought they would try DDT to wipe out malaria, which is carried by the vector as insects. And so they went ahead and tried this on an island as an experiment. And the island was Borneo. And DDT was sprayed to try and control malaria. Now, it worked. They sprayed, they killed all the mosquitoes. Malaria was gone. However, the lizards that fed on the mosquitoes died next. Now, that was a surprise because they sprayed this chemical, they exposed this chemical to cats and dogs and birds, and all those animals got healthier after they sprayed them with DDT. So the fact that the lizard died was quite a mystery to them. A little bit later, all the cats who ate the lizards also died. And now this was concerning. And of course, now that the cats are dead, the rodent population exploded, and the rats had fleas, and the fleas had the plague. And so now all of a sudden, the island becomes plague infected. And so the island is quarantined. Nobody's allowed to go there. In order to fix the problem, the British Army had to drop in British paratrooper cats to bring the rodents back under control. Kind of reminds me of a nursery rhyme about a little old lady who swallowed a fly, And the story goes that she continuously eats something bigger and bigger and bigger to try and control the initial small problem. Sometimes humans have that effect, and this was one case where they had a small problem and they did made changes without really thinking too clearly and created huge problems. Now, as soon as this problem came about, people started noticing there were other things happening as well. Uh, Birds, fish, frogs, harmless or beneficial insects like bees and butterflies were being found with huge amounts of DDT in their fat. So it turns out DDT builds up in the fat. So if you get exposed to any DDT in your life, it'll build up in your fatty tissues. If you get exposed to enough of it over time, it builds up because you don't lose your fat. Your fat stays with you forever. The concentration gets high enough, you get sick. High enough, it could kill you. Okay. Now, if we had this chemical is water soluble, this would not create the problem. You would get it inside of you, you would just urinate it back out. But because it gets stored in the fat, it's there with you for life. So essentially, all living things become this giant bowl for catching DDT. And if you catch enough of it, you'll eventually die. Oh, here is a nursery rhyme that we sang through in class. I got the Muppets to sing it. Because this is just a quick notes, I'm not going to go through that. More problems arose from DDT usage. Okay, so DDT remains in the environment. Remember, I told you it's a 100 years shelf life. Now that they found there was a problem, they realized this problem is going to stick around for 100 years because that's how long it takes for DDT to break down. And DDT was found in bodies of organisms all around the world, places where DDT had never been used. It turns out DDT was moving through the food web, and that was a real problem. So now you have it moving all over the world. You can't even contain it, and it's also going to be around for 100 years. So 1960s, 100 year, 2060, 2060, probably 1960s. We'll go forward 100 years, so that's 2060. Go forward another 50 years. That's so probably in the next 30 or 40 years, the DDT will be finished breaking down. Now, the birds of prey, the hawks, eagles, and ospreys, their populations fell sharply in the 1950s and 60s because of DDT. Now, DDT didn't make them sick. It made their eggshells thin, and so they couldn't have babies for a period of time, and their populations dropped. In fact, they almost went extinct, but a little bit of intervention from humans, and their populations are going back up, and they are stabilized now because most of the DDT is out of the system. DDT amounts is just I'm using DDT as an example. There's lots of other chemicals that will bio concentrate or bio magnify or bioaccumulate as they move up the food web. So here in this picture, you can see at the lowest part of the food of the phytoplankton, that's 1.7 parts per billion, and at the highest part, like the dolphins, 5,200 parts per billion, or if you want, 5.2 parts per million. And you can see as you move up the food web, it builds up. Well, it makes sense. There's a small amount in this fish, but the dolphin eats a lot of the fish, and so the DDT just keeps building up in its fatty tissues as time goes on. To put it in perspective, 1% is 10 million parts per billion, or if you want part per billion, 1 part per billion would be like if you take a chain of donuts and go around the entire planet twice, one donut in that chain would be 1 part per billion. So you can see very low concentrations. And you can see in the seawater, the concentration is very low, but as we move up the food web, the concentration increases. And of course, how does DDT enter into our food lab? Usually at the producer level. Okay. And then there's an assignment that you guys are going to do, page 191, numbers 1 to 911. You'll want to read page 190 to 191. It basically has the information I told you. To do page 191, there is a chart on page 190, basically this chart, but in color, that you will use in order to do it. Bad joke. What did James Bond do when he found out his room was bugged? He sprayed it with DDT. Now, what's bugging you? Some people took issue with the banning of DDT because it was helping them with their health problems, right? If you can kill the insects, that are bringing disease into your country, you can control the disease. They are trying to find a substitute. The WHO, which you guys have heard that word so much in the news for the last year or so, you all know that that's the World Health Organization. They screened over 2,000 compounds, haven't found a good replacement yet. They found some that work, but it was very expensive. It's expensive. It doesn't matter, right? The rural nations will not devote their money towards that. They also found out that as you use these pesticides, it made the pests evolve quicker and made them more resistant. So it's kind of ironic. The more you use a pesticide, the more variety of pests you're creating. And in this graph, it shows you that. So here's where they start spraying, and you can see the variety, the number of species of pests increases because of this. So pesticide resistance is an evolutionary result of actually using pesticide. If you didn't use pesticide, you wouldn't develop pesticide resistance. So what does that mean? It means once you start using pesticide, you're kind of stuck using it, because as soon as you stop using it, there's going to be a huge variety of pests that come up that will all of a sudden appear, and then as their numbers increase, they can then start to evolve and change in different ways as well. We're not going to do the graph. I'm not sure if we're going to do the graphing assignment. It'll say in your Google Classroom notes whether we did that or not. A couple of definitions you should know. Poisons refer to chemical substances in our food that cause illness or death. Toxins are protein molecules produced by biological organisms causing illness or death. Organic farming is farming without the use of fertilizers and pesticides or genetic engineering. There is a really cool video called Grocery Store Wars. So if you want to watch the video, you can. It's actually fairly entertaining. I'm showing it in class. I'm not putting it in this video because then all of a sudden I get these messages that I'm breaking copyright. So it's Grocery Store Wars. If you want to watch it, it's about a 4-minute watch. It's actually very entertaining. So where to now? We're concerned about the potential to harm non-target organisms led to greater societal emphasis on the control and appropriate use of such substances. So they're doing research and development in creating pesticides that break down faster, so they don't sit on the shelf for 100 years. They sit on the shelf maybe for 2 years instead. They're also doing some research into finding pesticides that are water soluble instead of fat soluble. That way, if you get some in yourself, you'll urinate it out and you won't become this sink for catching all this pesticide. They've also started looking at natural cycles and found ways to reduce the amount of pesticides being used by spraying at the appropriate time. Okay, and then here, that is the end of outcome number 1. So at this point in time, you do questions on page 196 in full sentence form, and we would be having a quiz relatively soon.